you got to keep up also with your questions, tutorial questions for chapter 4, which is on complex number, because we don't have much time left. We only have about like 1 month, all right, before our end of semester or before your final exam. Okay, so we would like to actually be able to discuss almost all questions from all chapters, okay, for this semester. Okay, so after this, you please keep up with your tutorial questions for chapter 4 as well. Okay, let us start with the first question. Anybody got any question to ask? Okay, I'm going to share my screen now. Okay, I think for real application question, basically is the language itself, right? You got to like a certain problem, you got to read more than once or perhaps 2-3 times, all right, before you can actually understand, perhaps. All right, and for the questions which diagram is given, then that is perhaps not to say is easy, but diagram will actually help you to solve the questions. Okay, you can figure out, okay, from the diagram itself. However, for questions in which diagrams are not given, so the first step is you must try to translate whatever given from the problem. Try to draw the diagram correctly. Okay, and I found that some of the questions is actually regarding the bearing, things like that. So make sure you know how to actually draw a bearing. Okay, all right. And for because diagram, why diagram is important, because if you wrongly drawn diagram, then perhaps you might also solve wrongly, okay, the question itself. Okay, then you get wrong answer. So diagram actually is important, okay, for this type of questions, applications of trigonometry, okay, where it can actually helps you to solve or to come up with a solution, okay, the correct solution. Okay, um let's look at now the first question. We are looking at exercise 3.6. Okay, 3.6 on page 1 to 1. All right, so this question is from Fatiha. Okay, the solution. All right, so let's look at the questions together. A plane leaves airport P and travels 580 kilometers to airport Q on a bearing of north 34 degrees east. Later, the plane leaves airport Q and travels to airport R 400 kilometers away on a bearing of south 74 degrees east, and sketch the positions of airport P, Q, and R. Then calculate the distance traveled if the plane flies directly from airport P to R. Okay, all right. You first of all, you must know how to draw bearing. Okay, so if you do not know how to draw it, then perhaps you might actually got the wrong angles, okay, in your diagram, in your triangles. Okay, and one thing for sure is that for these real application questions, okay, all real application questions on the trigonometry, basically it's all about triangle. Okay, it's all about triangle, because then you might want to apply, okay, you might want to apply whatever that you have learned, okay, regarding your triangle, or even oblique triangle, or even right angle triangle. So solving right angle triangle, basically you are using a simple trigonometric ratios like your sine, cosine, tangent, secant, cosecant, cotangent, okay, something like that. Okay, and using the another type, which is the oblique triangle, is when you have your law of sine or law of cosine. Okay, however, if you are dealing with right angle triangle, you can also use law of sine if you want. Okay, but it's much easier if we just use a simple trigonometric ratios when it comes to right angle triangle. Okay, now if we look at the first question here, okay, first of all, it's about bearing. So how to actually draw bearing? Okay, maybe this is just to is like a review session. Okay, perhaps just to refresh your memory. Okay, to draw bearing. Okay, like for example, like this question, this you have this north 34 east, north 34 degrees east. You have south 74 degrees east. Okay, all right. So basically you have like, if it is about like your north 34 degrees east, so basically this is your north, south, east and west. So when we draw bearing, is basically it's from north, it's from north as well as it is from south. Okay, it's always from either here or here. Okay, so we don't draw from east and west, we draw from north or south depending on the question. So if it is says north to east, so you going this way direction, this direction. If it is say north to west, you go that direction. Okay, and if you have like south to east, so going this way, south to west, going that way. Okay, so if you have like the first one here is north 34 degrees east, so you start from north going to the east side, all right, and make an angle of 34 degrees. So that means, all right, for this question, okay, assuming this is the line, this is 34 degrees like that. Okay, all right, so going that direction. Okay, and then another one is a south 74 degree east. Okay, so then you have your something like, okay, I just draw here first, okay, just to show you how to draw that south 74 degrees east. Okay, so again this is your north south, east west. All right, so south 74 degrees, so that means, all right, from south going to east direction. Okay, to the east direction, so you are going that direction. Okay, so which means 74 degrees, so you are making, for example, like this one. Okay, this is 74 degrees, so something like this. Okay, so then when you read the question carefully for this question, okay, you start from airport P and travels 480 kilometers to airport Q on a bearing of north 34 degrees east. So this is the one, north 34 degrees east, so that means, okay, which means this is your P is here, so that is P. All right, so travels like this, all right, direction. All right, and then you reach, okay, so that means this one. All right, so you are going to put it up here. Okay, so this one you are going to put it up here. Okay, so that means, all right, you have yours, here is your Q. Okay, so you have another bearing here. Okay, so this is south, east, all right, north and west. Okay, so with that south 74 degrees east, so which means again like just now, okay, assuming this is 74, all right, okay, so going that direction, okay, going that direction like that. Okay, to a point, say assuming that this is now your R. Okay, so basically you have this triangle. Okay, you have that triangle. So your triangle is something like that. And then from the question also, okay, it mentioned that uh, travels 580 kilometers to Q. From P travels 580. So here is 580, okay, kilometers to airport Q. And then from Q to R, okay, is 400 kilometers. So that means it's here 400 kilometers. So that is the distance there. Okay, so you are to find what is this one, the distance, okay, travel from airport P to airport R. Okay, so this is what you want. Okay, and from the diagram, okay, perhaps because we know that this is 34. Okay, so that is our 34, so we can actually find, okay, we can find our angle, isn't it? We can find our angle here. All right, we can also find our angle here if we want. If we want to find this, all right, we can. Okay, now whatever it is, okay, this one actually no need, because what you have is actually, you have, this is the side, okay, this is the side also, the one that you know, these two sides are known. Okay, and if you know the whole angle, okay, then you have like your case 3 of your oblique triangles. Okay, you have side, angle, side. Okay, so you have, this is what we call the included angle. Okay, since this is 34, so therefore you know that if this is 34, all right, this is also 34, isn't it? Okay, so this one is the one, this one, you know, this is also 34. Okay, 34 degrees. Okay, so which means the whole angle is actually is 108. Okay, so the whole angle here, all right, that is actually is 108 degrees. Okay, so the total, all right. Okay, so this is actually is the diagram, all right, and this is actually is oblique triangle, so it is not a right angle triangle. So this is actually solving for oblique triangle. So that means, okay, you are going to solve this using our law of cosine. Okay, so using law of cosine. Okay, now if I look at this diagram, okay, this diagram here. Okay, Fatiha, are you there?
Yes, madam.
Okay, do you understand my explanation here?
Yes.
Okay, all right. So this is actually is the right diagram. Okay, all right. But what you have here is actually is solving using law of cosine, which is correct. Method is correct. Okay, so using law of cosine. Okay, it's just that now the problem actually lies here is the angle for cosine. Okay, so basically this is actually is similar. This is correct. This is what we want to use. All right, which is the 400 squared plus 580 squared minus 2 times 400 times 580. But this is actually supposed to be cosine 108 degrees. Okay, all right. So then this is actually using law of cosine. Okay, however, this part, instead of 74, this is actually is 108. Right? So if I'm referring to your this con Q, that means this is the Q. Okay, this is the Q. That means it's the length of PR. Okay, length of PR. All right. So if you use this 108 degrees for cosine, so I suppose you will get different answer. All right. So Fatiha, can you compute this again? Can you give me the right answer?
Okay.
Okay, you just compute 400 squared, square root of, or either you take square root later. Okay, 400 squared plus 580 squared minus 2 times 400 times 580 times cosine 108.
799
7, okay?
99.86.
Okay, all right, something like that. Okay, kilometer. Okay, so that means this one is 799.86. Okay, kilometer. So that will be the answer. Okay, is it understood now for this question?
Yes.
All right, okay. Okay, the rest of you, any question? Any question for this question one before we move on to the next one? Okay, so next question is from Izati. This is okay. Question 2. You have also you are not given diagram, so it's about two station A and B, right? So two fire lookout stations are 15 miles apart with station A directly east of station B. Both stations spot a fire. The angular direction of the fire from station B is north 52 degrees east. Okay, and the angular direction of the fire from station A is north 36 degrees west. So how far is the fire from station A? Okay, all right. So, all right, so let's look at the diagram here. All right, so B oh sorry, station A directly east of station B. So that means directly east. So that means A is here, B is here. Okay. All right. And then it mentioned about these two stations are 15 miles apart. So that means the distance from A to B, or you say B to A, is 15 miles. All right. And then angular direction of the fire from station B is north 52 degrees east. Okay. So again, this is the one. All right. So that is the bearing. Okay. This is the bearing here. So that means this is your north. Okay. North east. Okay. So you have, this is 52 degrees. Okay. So north to east. So from here to here. Okay. So this is 52. Correct. Okay. And then another bearing from station A to the fire is, okay, this is north 36 degrees west. Okay. So again, so you see this one is north, this is west. Okay. So going this direction from north to west. Okay. From north to west. So this is 36 degrees. All right. Okay. So this is correct. All right. So that means this is now your fire. All right. So now let's look at this triangle now. So the triangle is now looks like this, where if this is 52, so you can find this angle here, which is in this case is 38. Okay. And because this is 36 degrees, so you can find the angle here, which is then 54. Okay. And you can also find this angle, because then you are given two angles. You have already found two angles. So then to find this, you basically just subtract by 180 degrees to get this 88 degrees. So basically, this is the right diagram. So based on this diagram, then question is asking you to find how far is the fire from station A. So basically, if I'm looking at this solution, okay, you're using X here. Okay, Izati, you're using X, so that means this is the X. Okay, so that is the X. So it's the distance, all right, from fire to station A. All right. So in this case, all right, you can actually use a law of sine, correct? Because you are given this distance, all right? So you have this angle, and you know this angle, so you can find this distance by using law of sine. So basically, this is actually by using law of sine. Okay, so then you can write in terms of x over sine 38 degrees, okay, equals to 15 over sine 88 degrees. So then you just need to compute correctly. Okay, I suppose this is also a correct answer. So you get roughly like 9.25 miles. So then you can conclude that the distance from the fire to the station, okay, is 9.24 miles. Okay. All right. Any questions? So this is question 2. Okay. If there's no question, okay, if you have question, you please ask. Okay. All right. Then let's move on to the next one. This is Nabila. All right. For question 3. Okay. Question 3, diagram is given. So when diagram is given, then this one you can at least you can actually get the idea to actually solve by using the diagram given. Okay, so then it's not that difficult. Perhaps it's straightforward. It's just that perhaps what you want to do is maybe you just need to just label the diagram, okay, based on whatever given information. All right, so Ahmad is flying a kite out on 500 meter of string, which makes an angle of 75 degrees with ground. while his friend Ali notes that the angle formed by the kite and Ahmad form his position is 102 degrees. All right. How far is the kite from Ali? Okay. All right. Perhaps maybe when you look at this question, sometimes the language how do I say? Actually, for this type of question, real application questions in this book, okay, there are actually some there are some typo error, as well as there are also sometimes there are grammatical errors, okay, grammatical mistakes. So I think on behalf of my colleagues also, I would like to apologize if you somehow when you read this, sometimes you get confused. Okay, so perhaps maybe in future they will actually rephrase okay the question better. Okay. Um, okay, but what information that you can find out, okay, you can dig in from this question is that okay, you have a diagram there, you have Ahmad. So basically this is Ahmad here, okay, so this is Ahmad here, and this is Ali. So this is kite, okay, so this is Ahmad is here, okay, this is Ahmad is here, and then you have Ali there, and then you have a kite here. All right, and that 75 degrees, okay, all right, is the angle here, okay, and that 102 degrees is this angle here. All right, and you have that 500 meters basically is actually is the length there, okay, from Ahmad to the kite. Okay, so once you actually label the correct, okay, labeling with the all in the diagram, okay, then perhaps okay, you know that what you want basically is how far is the kite from Ali. Okay, so what you want is actually is okay, let's see here. Okay, your friend use A, so that means this is the A. Okay, this is what you want to find. Okay, so that distance. All right, so this is just quite straightforward. This is an oblique triangle where you can just use your law of sine. So this is using, all right, law of sine. So this is how you establish your law. So you have your A over sine A equals to C over sine C. Okay, so all this labeling is from this diagram. All right, so basically it's the same as A over sine 75 degrees, okay, equals to 500 over sine 102. Okay, so normally when we put in information in the equation, normally we don't have to actually write this unit meter. Okay, no need to write this meter, just put only the value. Okay, final answer, yes, you can put your meter. This is mile, sorry. Okay, so this is mile, oh, meter, sorry, meter, yes, correct, m is meter here. Okay, so the last answer, then only you put your unit. Okay, so when you substitute into the equation, no need to put unit. Okay, so just put in the value only. Okay, so I suppose this one is correct. So when you compute this correctly, I suppose this is actually the correct answer. Okay, 494 meters. Okay, any questions? Any questions so far? Okay, let's move on to the next one. Number 4. Okay, 4 is from, oh, okay, 4 I don't have. So that means, Putri Natasha, I think, I suppose you want to share your answer? Putri Natasha Najwa?
Madam, I dah hantar dekat messenger semalam.
Ah, you send Oh, let me check.
Yes.
Okay. You give me your last 4 digit of your phone number? So I received too many, so maybe I overlook yours. You give me your last 4 digit, your number, handphone?
6514.
6514. Okay, let me just, maybe I overlook this. Oh, okay. You send me the PDF, no wonder. Okay. Oh, okay. No wonder I didn't actually, I forgot about this because this is PDF. So if remember I asked students to send just a photo image. Okay, because then if it's a PDF, I myself have to take a photo for this one. Okay, because I need to copy paste into my notebook. Okay. So next time, everyone, you just send me just a photo image for tutorial session. Assignment, yes, you got to upload, so you got to do it in PDF. Assignment, test, okay, final exam, yes, it should be in PDF. Okay. Alright.
Sorry, madam.
Okay, it's okay. No. Alright. If it is PDF, I cannot do like this. I have to upload if it's a PDF. So this is now question 4. I have to put it at the last page. Okay. Not this one. Is it this one? Hang on. It's supposed to be question 4, isn't it?
Ni 30.
This is number 20. Okay, let me check another time. Not this one. This is number 20. Oh, I only received this one. Question number 20. Oh, okay. Sorry. There's another one below. Okay, number 4, isn't it? Okay, all right. All right. Okay, so this one. Okay, so I hope everyone can see this. Okay, so this is question number 4. All right. Okay. Let's look at this question. All right. A pilot flies a straight path for 1 hour 30 minutes. She then makes a course correction heading 8 degrees to the left and flies 2 hours in the new direction. If she maintains a constant speed of 450 miles per hour, how far is she from her starting position? Okay, so let's look at this. Look at the diagram, look at the information. All right. So if we look at this, basically for this question, I suppose your diagram, okay. Okay, the diagram is supposed to be like this. You start from, let's say the pilot starts from one point, starts from one point here. Let's say from here, this is the point, starting point. Okay, and then flies in a straight path for 1 hour 30 minutes. So let's say it's a straight path to the left, just a straight path to the left for 1 hour 30 minutes. Okay, then she makes a course correction heading 8 degrees to the left. Okay, that means she just make a turn. 8 degrees is actually is here. This is 8 degrees. So she make a turn. Okay, make a course correction for 8 degrees. So 8 degrees is there. And then fly again 2 hours in new direction. So this is 2 hours. Okay, in a new direction. Okay, then if she maintains a constant speed of 450 miles per hour, how far is she from her starting position? So basically, what we want is actually is this. What is that distance? Okay, so maybe if I just okay, just put like maybe if you want to label, also you can. All right. So or you can just put like this is maybe just distance d. What is d? This is what you want. Okay, so that's the diagram. And what you can find also is actually is the angle here. Okay, that's the angle, you know, because this is 8 degrees here. So if 8 degrees is there, all right, so that means, all right, this is what, because this is a straight line. Okay, so that is a straight line. Okay, so that will give you 172 degrees. So you know that this is 172 degrees. So basically, you have your oblique triangle. So this is oblique triangle. All right, so you have your side, and then this is our included angle. So if you want to find this distance, therefore you are to apply, okay, law of cosine. So method here is correct, law of cosine, okay, that you want to apply. Okay, but before you can do that, okay, you need to find out in terms of length here, in terms of distance for both. Okay, so what you are given is actually is in terms of traveling, in terms of time. Okay, 1 hour 30 minutes, this is 2 hours. But because you are given this statement, okay, that a constant speed of 450 miles per hour, so that means 1 hour is 450 miles. So you just need to convert this 1 hour 30 minutes as well as 2 hours into miles. Okay, so which means, okay, this is the right calculation. Okay, so this is the right calculation. So this is in terms of miles. Okay, this is in terms of miles. This is the right calculation for the distance. All right. Okay, so which means, all right, which means this is 675 miles and this is 900 miles. So you have that. You have in terms of distance then. Okay, so then you want to just find another distance using your law of cosine. Okay. All right. So it will be 900 plus 675 squared minus 2 times 900. Okay, times this, but okay, this is the mistake, which is supposed to be, all right, cosine 172 degrees. Okay, Putri Natasha. Putri?
Dia reconnecting, madam.
Huh?
Dia tiba-tiba terkeluar, dia
Oh,
reconnecting.
I see. Oh, they're disconnecting.
Mm-mm.
Okay, because I'm using only one device. Normally, I would have my PC or laptop here. Okay, so that I can see it from the chat or whatever. Okay, all right, never mind. Okay, so the rest of you just need to double check this. Okay, so this is not the right answer. All right, so you just need to compute this later on. Okay, so get the right answer. Okay, so this cosine is cosine 172 degrees. Anybody have computed this? Anyone has computed this question? I mean, for the answer, what's the answer here?
1573.
You got 1573. Okay, so
1573.7, 1.8.
okay, so perhaps okay, the rest of you can also check if there's a discrepancy So 1573 you said 1573, something like that. Okay, miles. Okay, but the rest of you can also double check the calculation So basically it is this calculation is a square root. You're using law of cosine. Okay, the law of cosine. So square root of 900 squared plus 675 squared minus 2 times 900 times 675 times cosine 172 degrees. Okay, so don't forget to take the square root. Okay, so the rest of you can check the answer later. Okay, so that is number 4. Okay, then number 5. Okay, 5 is here. Okay, from Ukasha. Okay, this is 5. Okay, 5 diagram is given. Alright, so when diagram is given, so perhaps you can just figure out from the diagram, and if there's anything that you need to label, you label. Okay, or else if everything is there, then you just get your answer from the diagram. Okay, what do you want to find? Okay, so you have been given an assignment to mill a triangular shape on the CNC machine for a contemporary sign for the Department of Manufacturing Technology. The dimensions you are given by your manufacturing lecturer are shown in the following diagram. So what is the measurement of TS? So this is the diagram given. All right, you have your T, R, and S. Okay, that's the tip of the triangle. Okay, and the angle R here is 60 degrees. So the side here is given 30 centimeter. The side here is 21 centimeter. So this is what you want to find. Okay, so this is the distance that you want to find. So you can just use TS or D or whatever. Okay, so perhaps if I look at this answer here, your friend is using small r. Okay, so that means okay, so this is just a small r. So what? Oh, okay, that after all is given there. What is r? Okay. All right. So that's the length that you want. That's all. Okay, this is application. This is application questions. So basically, when it comes to application questions, of course, question will state what do they want you to find, like this one. So what is the measurement of TS? That's all. So they just want this only in the question. So they are not saying solve the triangle, like what we did. If it is not the real application question, so you are given a triangle ABC. A equals that, B equals that, this angle equals that. Solve the triangle. So if that's the case, all right, solving triangle means you are to find all the missing length and missing angles. Okay, but because this is application questions, so the questions are not saying solve the triangle. So question just based on the statement. Of course, it's a triangle. Okay, it's a oblique triangle, and straightforward. They want the measurement of TS. That means they want just this length. Because then when I look at the answer here, that means your friend is actually Ukasha. You are solving. You are giving us all the missing length and missing angles, which you don't need. Okay, you just give us an answer in terms of what they want. Okay, what question one. So basically just enough for this part only. That's all. All right, so basically it's just this part of the answer. Okay, so only this part, just for the first part, this one only. Okay, so the rest no need. Okay, the rest actually no need. Okay, so looking at here, so basically again using cosine rule. Okay, so using cosine rule. Okay, then you have your r equals to square root of 21 squared plus 30 squared minus 2 times 21 times 30 times cosine 60 degrees. Okay, so I think this is correct answer also, 26.665 centimeter. So that's all. Okay, that's what we want. That's what the question wants. Okay, just to find that length of TS. Okay, any question? Okay, then perhaps we move on to the next question. This is our last question in exercise in exercise 3.6. Oh, okay. Alif. Oh, yeah. Okay. I just got Alif. Question 6. I think it's somewhere down here also. Okay. This one. Okay. Okay, let's look at question 6. It's about a bicycle. Okay, there's no diagram here. Diagram is not given. Okay, it's a bicycle race follows a triangular course. The three legs of the race are in order: 2.3 km, 5.9 kilometers, and 6.2 kilometers. So find the angle between the starting leg and the finishing leg to the nearest degree. All right. So basically, it's an oblique triangle. So it's an oblique triangle. All right. So you are given basically all the three legs, the length of all the three sides. This is what it means, eh? All right. So in triangle, we call it also leg. And leg means all this length, this length. You have three legs like that. Okay, so you just need to just label. It doesn't matter which one which. So if I look at what your friends have here, right? So if A is 5.9, B is 6.2, C is 2.3. So this is your 2.3, okay? And then you have your 6.2, 5.9. So that means 2.3 here, 5.9, 6.2. All right. So basically, what you need to do is actually you need to figure out. Question asks you for the angle between starting leg and the finishing leg. So you just need to know what is the starting leg. So from here, all right, C is the starting leg, 2.3. Okay, because it says in order, 2.3 is the shortest. Okay, and then lastly, 6.2 is the longest, right? So this is the starting, and then this is the finishing. Okay, so that means this is the angle that we want. So this is what we call the included angle. All right. So when it is an included angle, all right. So again, you are using law of cosine. So you are using law of cosines. All right. But because all legs are given, all length are given, so what you want is only the angle. So from the law of cosine, you just need to rearrange and express A in terms of cosine inverse. Then you substitute correctly. Okay, so this is quite straightforward because these all are given. Okay, so basically, you just need to substitute into the formula. Okay, all the three legs here. Okay, again, make sure it's correct. Make sure it's correct. You cannot just simply substitute. Okay, so this is because you have a formula which is this a squared, okay, equals to this squared plus this squared minus 2 times this cosine this. So that the formula goes like that. Okay, all right. So you have your 6.2, all right, and then you have your 2.3, okay, minus 5.9, okay, all right. Okay, so this is correct. This is the correct setup. Okay, so I suppose this is also, if you compute correctly using your calculator, this is a correct answer. Okay, that is question 6. So that's the end for exercise 3.6. So then we move on to our chapter exercise. Okay, so starting from question 9.
Madam,
Yes. Okay.
kalau soalan tanya the nearest degree, so kena bagi nombor bulat ke?
Oh, yeah. Okay, this question asks for the nearest. Let me see question. Okay. Okay, yes, to the nearest degree. So that means it's not 71, but it has to be 72. So you got to give this answer. If it mentioned in the question, you must give us this answer. So if you don't give us to the nearest, then you still lose 1 mark. One last one. Okay, one last mark. All right. Okay, thank you. All right. Thank you. Okay, any more question? Okay, Ukasha also take note, Ukasha? Ukasha, are you there? It's not there. Okay, this is now question 9. All right. Okay, question 9 is where you have you're given a circus monkey is climbing a 25-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Okay. So let's look at the sketch. Let's look at the drawing. So basically, what you have is actually this is the pole. Okay, this is the pole. This is actually is a string. So you have a monkey climbing up like this. Okay, climbing a 25-meter long rope. Okay. All right, and then height of the pole. Find the height. Okay, so this is what the question wants. Find the height of the pole. So this is labeled by H here. Okay, and then the angle. Okay, the
Okay, Media.
angle. Is that Ukasha? Or is it?
Habis tadi dah cakap Alif ke aku.
Oh, Alif Oh, sorry. Alif just now. Question 6, isn't it? All right, okay. Okay, let's look at, okay, back to this question. Okay? Anybody got question there? Now, who is that? Who is that? Hello?
It's Ikhwan.
Huh? Sorry? Who is that just now? Okay.
He already.
All right. Okay. Back to this question 9. Okay. Back to this question 9. So look at the diagram. So that 30 degrees is here. Okay. Angle made by the rope with the ground level. Okay. This is the rope and this is the ground level. So this is 30 degrees. Okay. So diagram is correct. So this is a correct diagram. So basically, you just need to find the height. So basically, this is like your right angle triangle. So you can just use just a simple trigonometric ratio, okay, to answer this question. All right. So what you have here is sine 30 degrees equals to h over 25. So then h equals to 25 times sine 30. Okay, sine 30 is half, so times 25 is 12.5 meters. So that's the correct answer. Okay, so that is question 9. So, okay, 9 is quite straightforward. Okay. Okay, then let's look at 10. Okay, 10. Okay, just now 9. 9 is Bashira, just now. Okay, let's look at Fatini now. It's 10. Okay. All right. I hope everyone can see this. So basically, what you have is a man cut a pine tree and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. So the distance between the foot of the tree to the point where the top touches the ground is 9 meters. Find the height of the tree. Okay. All right. Okay, so basically this is okay, initially you have you have a tree, isn't it? So you have a tree. This is actually is a tree here. So that is a tree. So you have a tree. Okay, and then a man cuts it. So this part of the tree falls down. Okay, it fell, and then it bends. So here it mentioned here the broken part bends so that the top of the tree touches the ground. So basically, then you have something like that. Okay. So you have this is the triangle that you have. Okay. So that's the triangle. Okay. And what the question wants is actually is to find the height of the tree. So that means it's the height of the tree. Okay. So if you are referring to this triangle now, so basically the height of the tree will be this length plus with this length. Okay, so this length plus with this length. Okay, so that's the one, so that's what you want, for this question. All right. Okay, so back to this triangle. Okay, so triangle from Fatini here. So which means you need to find, okay, this one your friend labeled as A, B, C. All right. So height of the tree basically is this height AB, length of AB plus length of BC. Okay, so I can see from here actually this one, the last one here, this part. Okay, so that is the height of the tree. So that means you have to find height is AB plus BC. So that's what you want. Okay. Oops. Okay, so from the diagram also it mentioned about 30 degrees angle being here. Okay, angle, so that top of the tree touches the ground, making an angle 30 degrees with it. So this is 30 degrees. The distance between the foot of the tree to the point, all right, to the point where the top touches the ground is 9 meters. So this is 9 meters. So you have 9 meters here, you have angle 30 here. So you want to find AB, you have to find length BC, then you just add up. So this is also just a simple trigonometric ratios. Okay, because the fact that this is actually is a right angle triangle, so you can just use a simple trigonometric ratio. So you just need to find one by one. Okay, so let's look at here. All right, so your friend find BC first. Okay, finding this. So that means you find the relationship between hypotenuse, adjacent, and the angle. So which means that is cosine 30. So cosine 30 is adjacent over hypotenuse. So that means cosine 30. Okay, cosine 30 is AC. Oh, okay. All right. This one is a bit confusing when you write like this. So perhaps what you can do is you just put like this. In mathematics, you put like that. Don't equal it. All right. Equal means adjacent equals 3. This is what it means. Okay. All right. So which means that cosine 30, you are using exact value, which is 3 over 2. Okay. So you have your adjacent, which is in this case, this is AC. AC is 9. Okay, BC is the one that you want to find. So basically BC is your 9 times 2, all right? And then over, okay, so this one, okay. That's just a slight typo, I think. Fatini, this one. Okay, so 9 times 2. All right? Okay, typo, Fatini. Fatini?
Yes,
Can
madam.
you? Okay, so that's a typo there. Huh?
Sorry, madam.
Okay, so this is a typo. So double check. All right? Okay, so that is BC. All right, then you find your AB. So now AB is here. All right, so again, using tangent this time because tan is opposite over adjacent. So that is tangent. So this is correct, tangent. Okay. So you're using tangent. This is using cosine. All right, so okay, tangent 30 is 1 over 3. All right, so AB is the one that you want to find. AC is your 9 meters. Okay, so that is 9 over 3. Okay, this one is correct. So this one you just need to double check the answer again. So this is 18. So then this must be a different answer. What's the answer, Fatini? Can you compute?
15.59.
15?
0.59.
159. 159. Is it 15.9 or is
Yeah,
it
15.59.
Say again, I can't hear.
15.59.
Oh, 15.59. Okay, sorry. So 15.59. Okay, meters. Okay, all right. Okay, I suppose we can take a break. It's already 3 o'clock. Okay, so we'll take a break for 5 minutes and then we'll continue with question 11. Okay, question 11 from Intan. Okay, 5 minutes break. Okay, is everyone there? Let's continue. Okay, let's continue. Next question for question 11. Okay. All right. Before I look at this question 11, I will talk something about what we call the angle of elevation and inclination. You know, that type of concept. You have this terminology. You have angle of inclination or inclination angle, or sometimes they use the word elevation. So whether it's inclination or elevation, basically you are looking at angle, basically is from the ground or horizontal line, and then from the point, let's say this is a point, and then you are looking to the top. So this is what we call angle of inclination. Okay, angle of inclination or elevation. That's the one. Whereas another one is angle of uh, declination. Okay, it's like you decline. Okay, declination. So this is actually is the other way around, from the top, okay, looking down. Okay, so then this is the angle. Okay, so this is actually is the concept of what we call angle of inclination or elevation. So basically, if it's an inclination or elevation, you are at the ground looking up. Okay, if it's angle declination, from up looking down. Okay, so this is what it means. Okay, so for question 11, there's a word there, incline. Incline at an angle. Incline at angle. So incline means that inclination. Okay, so back to this. Okay, this diagram. All right.
Madam, how about angle
Yeah.
of depression?
Depression. Depression like
Angle of.
inclination.
Oh, okay.
It's the same as
Okay.
declination, depression. Okay. Okay. Depression also. Depression also similar to this. Okay. All right.
Okay, madam.
Okay. All right. Back to the diagram just now. Okay, this one. All right. So what you have is Azizul plans to make 2 slides for his daughter to play outside his house, and for the eldest daughter at age of 4, she prefers to have a slide whose top is at height of 1 meter and is inclined at an angle of 30 degrees. Okay, to the ground. Whereas for the elder daughter, she wants to have a steep slide at Actually, it's a steep slide at height of 2.5 meter and is inclined at an angle of 60 degrees to the ground. What should be the length of the slide in each case? Okay, now if perhaps, some people, you might actually find it confusing when you read this question. Okay, because the word is, when we talk about inclination just now, like I mentioned, inclination, the statement, the word must be, uh, inclination, the word must be from the ground looking up. Okay, so you are going to say from the ground to the top. Okay, looking at the top, looking to the top, or something like that. From the ground looking up. This is from the top looking down, going down. Okay, but question 11, they mentioned incline to the ground. So actually, this one can be like quite confusing. Okay, but I think the author, we have already informed the authors. All right. So the authors has actually take note. So I think in future they will try to make some correction for these questions. Okay, so that it can actually avoid some confusion to some people. Okay, because another confusion might be when you read the question. You have like eldest daughter, age of 4, and then suddenly you have elder daughter. Okay, so normally it's not supposed to be eldest lah. That one I think is the youngest. Okay, the youngest daughter. Okay, age of 4. So then it's between the youngest daughter and the elder daughter. So that's actually can be like quite confusing. Okay, when we read the question. Okay, but anyhow, this is actually is the, when I look at this diagram now. Okay, this is actually is the diagram that we want. Okay, so these are diagram. So which means you have the two slides. All right, so for this daughter is actually is the youngest lah, youngest daughter, because it's a small daughter. So that means, okay, of course you want to make a only that 1 meter height of slide. Okay, which is the elder, which is okay, a bit higher for 2.5 meter. Okay, so one slide is where you have 1 meter height. Okay, for the slide in which you have this angle. All right, angle inclination 30 degrees. Okay, to the, actually to the top, going looking up like that. So this is not to the ground. Inclination to the top, going up. Okay, 30 degrees. So another one is for the 2.5 meter height slide. So you have this 60 degrees angle of inclination. Inclination angle. Okay, so basically what we want is to find what is the length of this slide for both this slide and also the 2.5 meter slide. Okay. All right, so just you just need to solve separately for these two triangles. All right, and both are a right angle triangle. So you can just either use law of sine here, or you can just straight away use a simple trigonometric ratios. Okay, so a simple trigonometric ratios, because basically what you have is actually is the opposite over hypotenuse, okay, relationship, and then the angle. So basically both are is about sine 30. Okay, 1 over whatever here you call it. Okay, all right, so if they here your friends use a, so that means it's this a. Okay, all right, so you have your, so whether you use law of sine or a simple sine ratio is actually is the same thing. So you can use this one also like this. Okay, after all, sine 90 is 1. Okay, sine 90 is 1. Okay, so basically you have your 1 over sine 30, and sine 30 degrees is half, isn't it? Okay, so then that is 2 meters. So this one is correct. Okay, I think I would like to also remind you that perhaps this one is for everyone as well, because I noticed that when it comes to angle, even when I mark test also, even mark test assignment, when it comes to angle, okay, please by all means don't forget, if it's a degree, you put a degree notation. Okay, put a degree notation, because if there's no degree notation, then it could be it's a radian. Okay, because radian you don't have that notation. All right, only when degree you have that notation. So if it's a degree 30 degrees, put that degree notation. Okay, so don't forget that, because if you forget about that notation, then it can be like a different thing. It can be a radian there's no notation. Okay, all right, so this is for the first, perhaps in this case this is slide, the shortest slide lah, I call it. Okay, the shortest slide, which is the 1 meter height. Okay, the 1 meter height slide. And then another one is for the 2.5 meter slide. Okay, so same thing, similar. All right, so you just need either you use law of sine or you can just use a simple sine, all right, ratios. Okay, which is sine 60 or equals to 2.5 over b. So you can also do like that. Then you solve for b. So I suppose this is also correct. Okay, all right. Okay, any question for question 11? Any questions to ask? Okay. All right. So if not, then let's move on. Okay. If you have question, you just ask. Okay. Next one is question 12. Okay. The angle. Okay. This one I mentioned. The angle of elevation of the top of a tower from a point on the ground. Okay. So this one also is it's a bit confusing when they will actually rephrase this later on. Okay. The next. I think by next semester, not next semester, okay, the next new session, they will actually enhance this book. They will just make some corrections to these particular questions. So angle elevation, by right, it should be angle elevation from the ground to the top of the tower, okay? Because again, elevation, inclination, you are looking up. Okay, which is 30 meters away, 30 meters away from the top of the tower is 30 degrees, okay? Find the height of the tower. So basically, if we look at this diagram here, that for question 12, okay, so this is I suppose I can say that this is the tower. This is tower here. Okay, this is tower. All right, and then you have your some point here. All right, let's see, is a point here, and then this is the ground. Okay, so then you have the angle elevation here, there 30 degrees here. Okay, so 30 degrees there. All right, and then the distance from tower, this is tower. All right, is this distance is 30 meters. Okay, so basically what you want is to find height of the tower. Okay, question asks you find the height of the tower. So you want to find, this is what is the height. Okay, so the diagram is correct. So the diagram is correct here. Okay, so that means from the diagram you want to find what is AB. So this is what we want. Okay, so to find length AB. Okay, let me see this. Okay, because to find this length, basically you have this, you know this. If this is what you want to find, you can just straight away a simple, again, trigonometric ratios. Okay, where you have your tangent, isn't it? Okay, so you have your this is the opposite. This is what you want to find. Adjacent is given, and you know this angle 30. So just use your tangent 30 equals to let's say this is AB over 30. So AB is 30 tangent 30 degrees. Okay, what is this? Okay, let me just see this. So you find okay. So you don't need to find this. Okay, it's no need. So basically, okay, so perhaps if I look at bottom here, so this is C, okay, C over sine C, so that means C over sine 30, okay, C over sine C equals to A All right. Oh, okay. So if you use law of sine, yes, definitely you have to find this. But you know this is 30 degrees, so this is another 60 degrees. Okay, fine. All right. So okay. So that means you use this 30 sine 30 degrees over sine 60 degrees. So this is another way of doing as well. Okay, can also. Okay. So this one also can. So you have your okay. All right. So I suppose this one can someone compute this? What's the answer? What's the answer if it's like this 30 tangent 30 degrees? What's the answer?
Seventeen point 32.
17.32. This one, This one. Okay.
Yes,
Oh,
madam.
okay. All right. Okay. Now let me just read the question again. Sorry. I think it's something not quite right here. The angle elevation of the top of a tower. Okay, angle elevation of the top of a tower from a point on the ground. Which is 30 meter away from the top. Oh, okay. 30 meter away from the top. Okay, that means 30 meter away from the top to the ground. Okay, 30 meter away. Okay, so that means, okay. Okay, this one actually, not this, oops, not this. Actually, when they say 30 meter from the top, 30 meter from the top, so that means it's not 30 meters distance between tower and the bottom here. It is not from this to this. It's actually is from the top to the ground. So that means this is 30 meters. That is 30 meters. So which means, all right, it's not tangent. Okay, so then it's a sine. So that means it's a sine. Okay, because if that is 30 meters there, all right. So again, what you want is you know this. Oops, it's 30 meters. This is the 30 meters. Okay, this is all right. Oops, sorry about this. So this one is 30 meters here. Angle 30 is here. This is what you want to find. So it's sine 30 is this height over hypotenuse. So it is actually it's a sine. So sine 30 equals sine 30 degrees equals to AB over 30 meters. So then AB is 30 sine 30 degrees. Okay, can someone compute? Sine 30 is half, isn't it? So it should be 15. Right?
Yes, madam.
Yes,
It's
madam.
15. Because sine 30 is half, so half times 30 is 15. So basically this is the one. Okay? Alright? Okay. Jaya, this is your question. Jaya, are you there? Jaya Balan? Okay, Jaya. Okay, if you are listening, okay, I hope you take note. So basically, 30 meter is actually is from the top of the tower to the ground. Okay, that means it's from here to here. That is 30 meters. So it's not like distance from tower to this point. So from the top of the tower, okay, to here. Okay. All right. Okay, so that is 12. Then the next one is now 13. Okay, so that means okay, this is the answer, so it's not this. Okay, so even this one also is not 30 here. Okay, all right. Okay, so let's look at the next one. Okay, this is 13. Okay, Kaushan, I hope you are there. Let's look at this. Question 13. All right. Okay. Okay. There's a kite there. Kite is flying at a height of 60 meters above the ground. All right. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string to the ground is 60 degrees. Okay. All right. So then find the length of the string, assuming that there is no slack in the string. Okay. So that means you want to find length of the string. Okay. So if we look at this diagram, okay, so basically you just have this one, this diagram. You just have like this is something like this. Just a straight, just a right angle triangle. Okay, so this is kite here. Let's say this is the kite. All right, so you just want to find, this is a right angle triangle. So you want to find this is a string. Okay, so the height above the ground is given as 60. Okay, 60 meters, and inclination angle is 60 degrees. So you want to find what is the length of the string. So if let's say I put here is x, this is what you want to find. Okay, so basically it's just like that, the diagram. Okay. All right, so if I'm referring to Gaussian diagram here, so basically we can just extend from here. Okay. All right, so this is 60. Okay, so this is what we want to find. Okay, so something like that. All right. Okay, so again, this is just a simple trigonometric ratios, because this is the angle inclination 60 degrees. So this is the opposite over hypotenuse. So again, opposite over hypotenuse is sine. So just a simple trigonometric ratio. Okay, sine 60 degrees equals to 60 over x. So x is 60 over sine 60 degrees. So that's all. What is this? Can someone compute this? What's the answer? What's the answer for this?
69.
Say again?
69.28.
Oh, 69. 69.28. Okay, so that means 69. Okay, roughly 69. Okay, so which means this one. Okay, that's the one. Okay, so no need this. So only this part. So this one is using the law of sine. Okay. All right. Okay, so that is question 13. Okay, let's move on. Next is question 14. Okay, so it's the length of, okay, this one, there's a conclusion there. Correct. All right. Okay. Let's look at question 14. All right. Okay. Okay. So you have a 1.7 meter tall boy is standing at some distance. Okay. From a 29-meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building, and find the distance he walked towards the building. Okay. All right. So which means if I'm looking at this diagram, okay, so this is the boy here. All right. This is the building. Okay, I hope you can see this. That means the building is until here. The ground is down here. Okay, so that's the ground. So if you can see this clearly, so you have a ground here. So that's the ground. So that means the building, the 29-meter building is this the whole from the ground here, above the ground. So that is 29. So if there's a boy here walks, okay, so from his eyes looking up, okay, so the angle inclination or elevation, okay, increases from 30 degrees and then until here is 60 degrees. Okay, so as you walk towards the building. All right, so find the distance he walked towards the building. So basically what we want is actually this distance. Okay, this much. Okay, this much distance. Okay, let me see here. To calculate the hypotenuse sine. Okay, sine 30. Okay, so that means okay, so now it's referring to here. We are referring to this diagram because then, all right, we are looking at only this triangle, this much of the triangle. So we got to subtract this 29 by this 1.7 meter. So now the height of the building from the eyes is 27.3. Okay, so now referring to this diagram now. Okay, so basically you have like one big triangle here, as well as one smaller triangle like this. Okay, so you have one big here and you have this. Okay, so the distance that you want is actually here. So if only you can find distance from here to here, and then you can find distance from here to here, then you can find distance here. Okay, in fact this is how, if this is actually is a perhaps simple way of doing it. Let me just check what did your friend do. Sine 30, 27 over h. Oh, so your friend find this. Okay. All right. Okay. So then only using law of sine. So you are looking at just this triangle. Oh, okay. So understand. So you just find this. Okay. So you're using that. Okay. Okay. So this is, I suppose this one is okay. Okay. It's 27.3 over h. So sine 30. So get this and then looking at just this one. So if this is 60, this is 120. So this 30. So just use another law of sine. All right, that means x over sine 30. Okay, equals to this much over sine 120. Okay, all right. Okay, this is one way. I hope you can all understand. This is how your friend, this is number 14. 14, Wanjet. Okay, Wanjet, are you there? You Wanjet? Okay, Li Wanjet, are you there?
Ah, yes, madam.
Okay, all right. Okay, so I suppose you just look at only this triangle, isn't it? I mean, to find the x, you find
Yeah.
this hypotenuse. Okay, you find this hypotenuse from the bigger triangle. You find this, and then to find this x distance, you just look at this much. Okay, this is actually, yes, this is one method. Okay, another way perhaps also, what you can do is, because you are given also like these two triangles. Okay, so you can just use these two triangles without finding all this. Okay, without finding, right? So you just, it means that just use whatever is given from the question. So you have something like this. Just now, this is 30. Okay, this is 60, and then this is 27.3, and then okay, just now I mentioned if only you can find, okay, this is what you want. You want to find this length. This is what you want to find. Okay, so that length. So let's say you say that this is you want to find x. So if only you can find the whole length, you find the whole length, and then you subtract by this length, then you can also find x. So that means if let's say let's say this is y, and then this is z, for example. Okay, so that means to find the x, right, is where you have your z minus y. So basically, you just use whatever is given from the question, okay, without finding the rest. Okay, like that, like this one, you find this information, okay, like angle here, angle here. Okay, this is also correct. Okay, correct concept also. But another way of doing is just based from whatever is given here. So we can just find the whole length stretch z here, and then we find the y. So we just subtract to get the x. So this one also can be done that way, because then we can just to find the z. Okay, we are looking one big triangle. Okay, so to find the z, we just need to find one big triangle, which means that you have, if I'm looking at a big triangle, so I can just use this, what you have here is opposite, all right, and then adjacent. So we are using tangent. So that means tangent, that means tangent 30 degrees, okay, equals to 27.3 over z. So z equals to 27.3 over tangent 30 degrees. So you get one answer. Okay, and then look at now this triangle only, the triangle with the 60 degrees angle, to find the y. So also tangent, but this time tangent 60. Tangent 60 is 27.3 over y. So another one, okay, is tangent 60 degrees equals to 27.3 over y. So then y equals 27.3 over tangent 60. Okay, then only finally, all right, x equals z minus y. So then you just subtract. Okay, did you get the same answer or not for this one? Wanjet, can you try to compute? What do you get? What is z? Wanjet, can you help me compute this?
That is 47.28 degree.
47.28. Okay, this one is length, isn't it? Okay, another one. This is meter. Why?
Y is 15.76 degree.
15.67 meter. Okay, it's no
Yeah.
angle, eh? Okay. Okay, subtract those two.
$31.52 meter.
Okay. Okay, so same, eh? Alright. So either you use this or you can use this. Okay? Alright, so again, it depends on how you see it, isn't it? So that's why I always tell everyone that, during the test or even final exam, when you want to answer, it's actually, it depends on your own understanding. Okay? And there is no like one exact method to do. So you may have like more than one ways to do this. Okay, so this is 14. Any question? Alright, let's move on to 15. Okay. Alright. Okay, so this is 15 from Loga Piritan. 15. Okay, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degrees and 60 degrees respectively. Okay, find the height of the tower. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degrees and 60 degrees respectively. Find the height of the tower. Okay, so basically, all right, this question 15. Okay, so this is the building here. This is building. Okay, this is building. So this much is a tower. Okay, so you have tower there. Okay, and then you have a point P there. Okay, and the point P. And then you have two angles elevation. All right, one is 45 degrees. So this 45 degrees is the angle elevation from the point P to the top of the building. This is top of the building. From here to here, this is top of the building. So this angle is 45 degrees. And then whereas another angle elevation from the point to the top of the tower, the whole stretch here, the whole angle here is 60 degrees. So basically, all right, this is the diagram. And what you are given from the question, okay, is a 20-meter high building. So you are given this. You are given this. Okay, this 20 meters tall. I mean height. Okay, height of a building. All right. Okay, if this is 20, okay, of course you can see your friend put here 20. Why? Because this is 45 degrees. So when this is 45 degrees, so if we look at the right angle triangle with a 45 degrees here, 45 degrees here, that means these two lengths are the same. So when these two lengths are the same, if this is the given 20 meters, so this one also is 20 meters. Okay. So even though this is not given in the question, but it's understood because this is 45 degrees. So 45 degrees, if this is 20 meters, this is also the same length. All right, so these are all the information you can put down on a diagram. Okay, so then let's look at the question. The question wants you to find height of the tower. So question just want this much only. AC. Okay, find AC, length of AC. Okay. All right, let's look at this. Okay. One big ground angles, elevation. Find AC. So you have your 90 degrees in right angle triangle APB. Okay, you have here tangent 45 degrees. Okay, tangent 45 degrees equals to 20 over PB. Okay. Okay, so that means PB is 20 lah, isn't it? Okay, so this is the one. All right. Okay, so in right angle triangle CPB, all right. Okay, tangent 60 equals to BC, okay, over 20. Okay, all right, so BC is 20. Okay, all right. Okay, so I suppose this is correct. So that means you just need to find the whole height and then you subtract, isn't it? So AB plus AC. So you get this AB plus AC. So you already got AC, so then you subtract. Okay, so AC is just subtract your BC minus AB, isn't it? Okay, BC minus AB, you get your AC. Okay, I suppose this is correct. Okay. So basically this one is where you have your this one is the AB plus AC equals BC. So this one BC, you got it from here. So you want, so AB, all right, AB is from your just now given. So AB is given, BC you just found from here. So therefore your AC is just your BC minus AB. So I suppose this is correct. Okay, question. Can you all see this? Got 2 pages. All right. Okay. So you got 2 pages here. If you want to see this, the whole thing. Okay, 15. Any question 15? All right. Okay. So then let's look at the next one. Okay, next one. Oops, next one I don't have 16. Moses, do you have yours,
Yes.
Moses?
Yes,
Okay,
madam.
so
Yes,
you would
yes.
like to, okay. Can you share on the screen? Okay.
Can see, madam.
Okay, can.
Okay.
All right. Okay. All right. Let us see that. Okay. So you have a statue. All right. A statue is 1.6 meter tall, stands on the top of pedestal from a point on the ground. The angle elevation of the top of statue 60 degrees, and from the same point the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the pedestal. Okay, I think this one is similar to question 15, isn't it? It's just that the other way around. Just now you have your tower. Okay, you have your tower, and then you have your building and tower. Tower is on top of the building. This time you have a statue on top of the pedestal. So pedestal is like a building also. Okay, so pedestal is on top of the uh, um, statue is on top of the pedestal. Okay, all right. But this time, okay, just now we want to find the height of the tower. So now we want to find height of the building, which is the pedestal. Okay, so this time is the other way around. But angle given, angle elevation is similar, 45 degrees and 60 degrees. So that means to answer this question also is a similar concept. Okay, it's just that you need to know which one now you want to find. Okay, which height. Just now is height of tower, now is height of the building or pedestal. Okay, all right. Okay, let's see this. Okay, where is it now? Okay, all right. So that means from your diagram, what you want is now to find BD, isn't it? Okay, so you want to find BD. Okay. Can you make it bigger a bit, Moses? Okay, all right. Okay. A little bit, okay. All right, okay. So you're looking at right ABC, the right angle triangle ABC. So you have ABC. So you have your tangent 60. Okay, the bigger triangle, tangent 60 is AB over BC. Okay, all right. So tangent 60 is 3. AD plus, oh, okay. So AB is AD plus DB or BD, okay? All right, over BC, okay, this one. And then, okay, so that means it's 1.6 plus BD, okay, over BC. Okay, all right. So BC is 1.6 plus, okay, so this is first equation. So one equation is where BC equals to 1.6 plus BD over sec3. Okay. And then look at the another triangle. Okay, the 45 degrees triangle. Do the same thing also. Tangent 45. Okay, equals to BD over BC. Okay. All right. So you have your tangent 45 is 1, correct? So then basically oh, okay. Equation 2. Equation 2, Moses, I think there's a typo there. Is supposed to be BC equals BD, not equals BC minus BD. Right, Moses?
Yes, madam. Yes, madam. My mistake.
Okay, there's a typo there. Okay, there's a typo. Okay, it should be equation 2 is BC equals to BD, eh? Okay, so you cross multiply BC by 1, so BC equals BD. So that is, okay, maybe you can write something, okay? You can write, right? Or you just project, you don't have something to write. Can you, or is it, because I don't have, normally I can
Oh,
request. So this,
yes, madam.
this time, like, this
Because I
time,
open in the web.
oh, okay. Because normally there's something that like I can request to write, but this time I cannot see anything for me to request.
Oh,
Okay,
okay.
never mind. Okay, so
Oh,
that means,
edit. Oh, I
you,
right, madam.
oh, you cannot write. Okay, never mind. Okay,
Oh,
I hope
okay.
everybody can see the bottom part. Okay, that it is supposed to be BC equals to BD. Okay, so that is equation 2. So I'm looking at equation 2. Okay, you guys out there. So BC equals to BD. All right. Okay, so then you just need to equate, right? Both equations, isn't it? So you equate both equation, okay? Equation 1 equals to equation 2, and then you can actually solve for BD. Okay, so the steps is correct. Okay, so the step is correct here.
Okay.
All right, so let me just, Moses, what happened?
Yes, madam. Closed.
It's closed already. Can you show again? Just one more time.
Can madam.
Okay, all right. Okay, can. Okay, so basically you just equate the two equation, then we can solve for BD. So BD equals 1.6 plus BD over Z3. Okay, so I think this one should be okay. So that means 1.6 over Z3 minus 1. Okay, I think this one should be okay. We just need to compute. Okay, BD equals to 1.6 over Z3 minus 1. I hope people can see this. So straight away the answer, we don't have to actually go further, Moses. No need to go further. All right. No need to go
Oh,
further.
okay.
You just stop until there. You can see BD equals 1.6 over 3 minus 1. Can you like doing like some sort like a circle, highlight that part for your friends? Can you do that?
Which one?
This one. Yeah, you just show that part to your friends. The BD, yes, this one. Yes, that one. Okay.
No.
All right.
Okay.
You just stop until there. Okay, you can just stop there. BD equals to 1.6 over 3 minus 1. Or perhaps you might want to just use calculator, because after all 1.6 is a decimal. Okay. All right, 1.6 is a decimal. So normally we don't mix up numbers like decimal with the exact value. So 3 is the exact value. 1.6 is already decimal. So just need to compute 1.6 divided by 3 minus 1 in terms of decimal. Okay, so to find the length of BD. Okay, so no need to go further down. Okay, so no need to go further down. So until there, that's the answer.
Oh, okay, madam.
Okay, all right.
Okay, madam.
Okay. Okay, thank you very much. So I suppose it's already like 4 o'clock. Okay, it's almost 4 o'clock. So maybe I can just stop here until question 16. All right. Anybody got any questions? Anybody got any questions?
No, madam.
Okay, so for next week. Okay,
No,
so for next
madam.
week. All right. Okay, good. So for next week, I will again I will select some of the question based on the solutions that I received from all of you. I will select some because I don't think that we will have enough time to discuss all. Okay, from 17 onwards until 33, that is actually is too many. So I will select some because I think I might want to also start looking at tutorial questions for complex number. Okay, so maybe for next week session for tutorial, maybe we spend like the first 1 hour we discuss some of the selected questions, and then the next 1 hour we will start discussing tutorial questions on complex numbers. So in the meantime, I would like you to keep up with the tutorial questions for complex number. Okay, so the earlier part, okay, especially the one that we have talked about in during lecture. All right, and for this application question, I am going to just select a few. So the ones that I did not select, I will actually look at it also. Okay, so don't think that it's a waste of time for you guys to actually do it and send to me. After all, once if you have been assigned, I'm sure that you will put your like heart and soul to the question, isn't it? So you start off, start to think how to actually answer the question, which is actually is good. Okay, good exercise. Okay, so I will select some of the questions to be discussed further next week for the first 1 hour. Then the next 1 hour we'll discuss some of the tutorial questions on complex numbers. So in the meantime, you please try to catch up, everyone, with the complex number questions. All right. Okay,
madam.
if there's no
madam.
okay, so
Okay, madam.
all right. Okay, so if there's no question, then perhaps we can end the session now. All right. So thank you very much for your attention. All right. And have a good weekend. Stay safe. So I'll meet you again next Tuesday, inshallah.
Thank you, madam.
Okay. All right.
Madam.
Okay. Welcome.
You too,
Thank you, madam.
Assalamualaikum.
Stay safe too.
Okay.
Okay. Thank you.